సబ్స్క్రైబ్ చేయండి ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి ప్లీజ్ లైక్ అండ్ షేర్ చేసి కామెంట్ చేయండి
differential form of Gauss's law. Differential form of Gauss's law. First of all, this is the closed surface. This is the closed surface. This is the Gaussian surface. The volume of this surface is the V. Let a charge Q is uniformly distributed. Uniformly distributed means the Q charge is uniformly distributed over the total volume. So at the same time, the density of the Gaussian surface, this is the rho. First of all, the charge is defined as Q is equals to volume integral rho dV. This is the definition of charge over the closed surface area. This is the density, this is the volume. So Q is equals to volume integral of rho dV from what is the Gauss law is equals to phi suffix E is equals to closed surface integral E dot ds is equals to Q upon epsilon naught. Okay, this equation can be written as epsilon naught into closed surface integral E dot ds is equals to Q. From these two equations, this equation and this equation, then epsilon naught closed surface integral E dot ds at the Q, we substitute this equation. Epsilon naught surface integral E dot ds is equals to volume integral of rho dV. We know that Gauss divergence theorem, the surface integral, closed surface integral is converted into volume integral. Then from this conversion, the Gauss divergence theorem is equals to closed surface integral E dot ds is equals to volume integral of div E into dV. Divergence E into dV. This is the Gauss divergence theorem. We know that this is the Gauss divergence theorem. Since the closed surface integral is converted as volume integral. Okay, from these two equations, epsilon naught, then closed surface integral E dot ds, is equals to volume integral of div E dV is equals to volume integral of rho dV. Then so if integral must be equal, LHS and RHS integrals must be equal, then epsilon naught divergence E dV is also cancel, that is equals to rho. Then divergence E is equals to rho upon epsilon naught. rho upon epsilon. Div is the del dot E. Divergence E is equals to del dot E is equals to rho upon epsilon naught. This is the differential form of Gauss law. This is the differential form of Gauss law. But we know that the electric displacement vector D is equals to epsilon naught into E. Epsilon naught into E. Then electric field is equals to displacement vector upon epsilon naught. Epsilon naught. This equation, substitute in this equation, del dot E is d upon epsilon naught is equals to rho upon epsilon naught. Epsilon naught is the cancel. Del dot d is equals to rho. That means divergence displacement vector is equals to rho. This is also another differential form of Gauss law. This is also another differential form of Gauss law.